All right, so what we have here is less of a warm up, and more of a cool down. So again, we kind of flipped the script a little bit this class. Instead of doing a warm up, we're going to do some classwork practice at the end. So read the following article about the connection between vitamin E and heart bypass surgery. All right, vitamin E may have special health benefits. Large doses of vitamin E apparently can reduce harmful side effects of bypass surgery in heart patients. A study involving 28 bypass patients found that 14 randomly assigned patients who took vitamin E for 2 weeks before their operations had significantly better heart function after the procedure than 14 randomly assigned patients who took placebos. The vitamins apparently prevent damage to the heart muscle by destroying the toxic chemicals called free radicals that form when blood is cut off during surgery. Dr. Terence Yao of the University of Toronto. So part A, explain why this is an experiment and not an observational study. All right. It's an experiment because the reason is a treatment was applied to the subjects specifically vitamin E. Okay. Explain the explanatory and the response variables. All right, so the explanatory variable is amount of vitamin E. All right, and this doesn't really tell us whether everybody got the same dose or not, but basically we're looking at whether or not you got vitamin E. And then the response variable is something that deals with like heart function. We don't know exactly what they were measuring, but we do know that in general, they're kind of looking at heart function and how that's affected, after surgery. All right, identify the type of experimental design used in this study. All right, so again, that goes back to this description up here, where it's telling us that 14 randomly assigned patients who took vitamin E and 14 randomly assigned patients who took placebos. All right, it doesn't mention any sort of blocking or anything like that. So that leaves us just to assume that it's just a randomized comparative experiment. All right, and again, there's no mention of blocking or a completely randomized design. Now, it's possible it was completely randomized and they just ended up with 14 in each group, but it seems more likely that it was just a randomized comparative experiment where there was no mention of blocking or completely randomized design, but, patients were randomly assigned to each group. In the second sentence above is the phrase, the 14 patients who took vitamin E for 2 weeks before their operation had significantly better heart function after the procedure. What is the statistical meaning of the word significantly in the context of this study? All right. So significantly, when we're talking about statistics, means the results / improvement was larger than what could be reasonably expected from random variation. All right, so the big idea there is if you split two groups up, even if the treatment makes no difference, you're not going to assume that they're going to get exactly the same results because things happen in the real world and the odds of the results being identical are pretty slim. Chances are one group's going to do a little better, one group's going to do a little worse. The question is, how much better, how much worse? And when that gap is large enough that it's more than could be reasonably expected from random variation, we call it statistically significant. All right, this was a controlled experiment. Describe how it was controlled and explain the purpose of doing so. All right, so the control basically was the placebo pill. All right, so you had two groups. The treatment group took the vitamin E. The control group took the placebo. All right, and this gives you a baseline to compare the results of the treatment group. All right, so the control group gives you that baseline so you can actually measure, how much of an improvement did vitamin E actually yield in terms of heart function, right? But if we don't have this control group as a basis of comparison, then we don't really know how much of a difference that it made, all right? And obviously, they took the placebo to try to neutralize impact of the placebo effect, where people feel better just because they took something, even if that something doesn't really have any medical value. All right, so let's take a look at the back here. 2, as a researcher for a pharmaceutical company, you are designing a study to test the effectiveness of a new treatment for migraine headaches. You have been given a list of 126 people willing to participate in the trial. The first 70 people are female, the remaining 56 are male. Preliminary research suggests that men and women respond differently to this new treatment. What sort of experimental design would you choose for this study and why? All right. So if there's a trait that you can identify that could have an impact on your results, then you want to control for that trait. And we control for that trait by creating blocks or groups based on that trait, and then making sure the treatment is balanced across those groups. So the name of this is a randomized block design. And this helps control for the impact of gender by guaranteeing or by ensuring the treatment is split evenly across groups, across blocks. All right, so we don't have to worry about randomly ending up with more females in one side and more males in the other side, or vice versa, which could lead us to think that the drug is doing one thing when it's actually just because we ended up with more males or females on one side of the equation. All right, explain why an experiment involving 70 women and 56 men is preferable to one involving 10 women and 8 men, right? So this deals with just basically random variation and that idea of replication that we talked about earlier, but with more participants, there is less chance of random variation, causing a misleading result. All right, and then I'm just going to add here, because this is important, it should make it easier for other researchers to replicate your results. Right? Because they're more reliable. All right, that's a big part of science, and that's a big part of research. You know, one group performs their experiment, they get the results. It's important that other groups, you know, run those same experiments, try it out, make sure that the first group didn't get some sort of anomalous result that was just, you know, bad luck or good luck, depending on the case. But, you know, looking at these things and making sure that you have enough people so that random variation isn't causing you to reach some conclusion that isn't really justified. And again, the smaller your group, the higher likelihood of that happening. All right, the larger your group, you know, the less likely that's going to happen. When you're dealing with really small samples, you know, fluky things can happen. When you're dealing with larger samples, fluky things can still happen, but it's far, far less likely. So when people go to replicate your results or replicate your experiment, they have a more reliable baseline than if you have a really small sample at the start. All right. Finally, last but not least, describe a design for this experiment. Be sure to include a description of how you assign the individuals to the treatment groups. Okay. So what we could do is we could say something like, create a block of 70 females. Okay. Step 1, generate 35 unique random numbers between 1 and 70. All right. Those people get the treatment. The other 35 get the placebo. Okay. Then create a block of 56 males, and then pretty much do the same exact thing, only we're going to be generate 28 unique random numbers between 1 and 56, and then the same thing. Those people get the treatment. So a lot of writing, but pretty much the same exact thing. Get the treatment. The other 35 get the placebo. All right. And then, yes, we divided these up into groups, but we still want to know the overall results. I mean, we divided them up into groups to make sure that males and females were balanced because we thought that might have a role. But at the end of the day, we're still measuring the effectiveness of the treatment. So, calculate results for those receiving treatment. And I'm going to put in parentheses both genders. And do the same for those receiving the placebo. All right, so obviously, this is a pretty long description here. This is very thorough. As far as the stuff that definitely needs to be there, I definitely need you to be saying that you're creating a block of females, you're creating a block of males. I need you to at least once say that you're generating unique random numbers and explaining how you're using those random numbers to split up the treatment and the placebo. This sentence, could I have just said, repeat the random assignment for the males? Yeah, as long as you did it the first time up here. If the second time you just said repeat the process for the males, I would be fine with that. But at least once, I need to see a sentence that sort of refers to generating unique random numbers. And I definitely need to see the part about creating the blocks. This one could probably be simplified to something like repeat random assignment for males, because if you wrote the sentence correctly for the females, I kind of know that you can write the sentence correctly for the males. So if you're looking to kind of shave it down a little bit, that's one way you could do that. All right. So again, I hope this was useful. If you have any questions, let me know. But this is just kind of going through and, hitting on like a lot of the different vocabulary, the difference between an experiment and an observational study, difference between explanatory and response, knowing the different types of experimental designs, randomized block, knowing this phrase statistically significant. All right, that's really what this is going towards, is the phrase statistically significant, control and what that really means, and then blocks and stuff like that. This vocab is the stuff that's going to show up on your test, so just make sure that you're comfortable with that. All right, that's all I've got for today. So have a good one, and as always, reach out if you have any questions. Bye.